Of course, thank you for the intro. Very happy to be here, everybody. So today we're going to talk a little bit about how to do password cracking. We'll start off with some basics and fundamentals as to how passwords are stored and what are some of the techniques that we can do in order to break some of those security mechanisms. So if you've never done anything with password cracking before, this should be very interesting. If you have, hopefully it can also serve as sort of a review here. So let's talk about this. So the very first thing with password cracking is you need to understand cryptographic hash functions. That is the fundamental basis to how passwords are stored in the modern age here. So cryptographic hash functions, if you're not familiar with them, they're what's called a one-way function, meaning that once you have the function run through, it is practically impossible to invert that. The only way to invert the function is through brute force. And when I say function, I literally mean like a math function. You have an input and you have an output. It only goes one way. You cannot revert it back. The only way to do it is through brute force. Another attribute of cryptographic hash functions is that they're fixed size outputs. What that means is that any size input will always yield the same output length. Now, this is generally useful for storage purposes because then you can store the hash of a very, very large input as a fixed size. You don't have to worry about your inputs being too big and that overwhelming your storage. It is also deterministic, meaning that the function will always generate the same output based on the same input. It will also always generate different outputs if you put in a different input. The very last part of this is that it's fast for the most part. The hash functions should be able to ingest in a very, very large amount of data or very little and should still be able to actually compute that output in a very fast manner, given any amount of size of input. Now, these things you probably have actually seen or heard before. The major cryptographic functions that are in use today, MD5, SHA-1, 2, and 3, which are all standardized by the National Institute of Standards and Technology, along with several other organizations out there as well. So what these things do for us is that they provide for us a way to securely store passwords without using the plain text of the password in our database. Because before, let's say 10 years, 15 years ago, what a lot of service providers even then were doing was basically taking your plain text password and then storing that in the database. And even today, some older organizations are still doing that, which is a very poor way of storing passwords. So I'll talk about how do you store passwords with these hashes. So let's give an example here. So for hash functions, generally you take the message goes into a hash function, and then that yields out a hash digest. That's what the output portion is called. So let's say you have the phrase profits as your message, and then you run that through a hash function. That might spit out a hash digest that looks like what you have on the right-hand side there. But if you change it ever so slightly, you say profits are down, and then you run it through a hash function, you'll see that the hash digest there is now completely different. They don't look anything remotely similar. It kind of just looks like gibberish at the end of the day. And that is exactly the point there, is that they should look fairly random. And then again, if you add something else into it, profits are down 25%. Now the hash digest there is different. Once again, there's not a whole lot of repeating characters or sequences that you'll see. They look completely different from each other. And even the smallest tweaks, actually, for example, if you do profits are down 26%, the hash digest there will also be basically completely different there. And that's a very important part to the properties of a hash function here, is that similar passwords then will not look similar in the hash digest, so that people cannot just go in and start guessing passwords based on, there's some similarities there. Now, how can you actually use this as an individual? If you're not familiar, there's several ways that you can do this. One of the easiest ways that you can do this within the browser is actually through a tool called CyberChef. CyberChef has all these different things that they call recipes, which are effectively just different kinds of functions that you can run through. So you can take the recipe MD5, for example, and then you can put in some input there, say profits are down 26%, and it'll give you that output right there, which is the same thing that I showed you in the previous slide. So this is one of the quickest and easiest ways to do it. Now, of course, for good cybersecurity professionals, we want to also learn how to use this on the command line. So what you can do is run, for example, the command echo, and then you pass in the string profits are down 26%, for example, there, and then pipe it to a command that is frequently available on Linux machines and also on Macs. I think the one on Mac is just slightly different, but you can pass it to a command called MD5 sum. And the MD5 sum command will there generate the hash digest as well. Now, one of the things to be very, very careful when executing this on the command line here is this is actually incorrect. So a lot of us will probably just run echo, do this thing, and then pass it through MD5, and then think, all right, we've got it. This is good. If you recall from the previous slides, profits are down 26%. We executed that through a hash function. And then what I demonstrated here on the block side right here is this sequence that starts with 9314. You'll see that this starts with BCCB. So that is not at all the same output. That is because echo actually puts a new line character at the very end right there. So that new line character is actually being fed into the MD5 sum command as well, which is causing the hash digest to be completely different. Like I said, even one character change will make the hash digest there completely different. So in order to compute the correct hash digest here, you'll need to run echo with the -n option, which tells echo to not insert the new line character. In this case, when you run it through MD5 sum, here once again, you'll find that the new hash digest in the terminal output matches also what I had shown you from earlier. So this is just a very small intricacy. I still miss this occasionally from time to time. So this is something just to be reminded of when you're running MD5 hash sums on the command line here. So now that we've kind of understood how cryptographic hash functions work at a basic sense, let's look at them within the password use case. So let's say you have a password, you're super secure, you have something that's called my secret password, you got uppercase, lowercase letters, you got some special characters involved in there as well. So what happens to a good, a well-architected and a good software programmer's application is that they will take this password and then they will hash it and then store it into the database. So they're not going to take my secure password and then store that in plain text. They're going to take that hash digest and then store that in the database there. The reason for this is because if the database is ever breached, the user's passwords are not then just immediately compromised because the hashes are inherently non-reversible. Now, that does not necessarily mean that the passwords are completely safe, because what somebody could do is go through and start brute forcing the hashes and then figuring out what was the original plain text. And that's what we'll talk about in just a moment, how to do that particular process. How do we crack these password hashes? Now, like I said from earlier, service providers are not necessarily obligated to do this. There's not necessarily a universal regulation that says you must do this. It is generally best practice, and a lot of more regulated industries are required to do this by the industry's regulations, for example. But like I said, a lot of organizations do not do this, even to this day. So one additional layer that we can add on top of this, and this is where things start to get a little bit more complicated if you want to protect your users a little bit more, is that instead of simply taking my secret password and then hashing that and then storing the hash digest in the database, what you can do is something that's called password salting. And it literally works like this. You take the user's password and you append it or concatenate it with a salt value that you randomly generate for a given user. Some services will only generate a salt for the entire system. Some services will generate a unique salt for every single user, such that it provides an additional layer of protection against password cracking. So what they will do is then take my secret password, concatenate it with salt1, the combined entity there, they'll run that through a hash function right there, generate out the new cryptographic hash digest, and then they'll store it into their database. And let's say that goes to some video streaming website. Because then now you have a different hash digest, so that the original passwords, even if people use the same passwords, because of the addition of that salt, now the hash digest looks completely different, so that attackers aren't able to utilize what they have previously discovered about a potential plain text password against maybe a hash digest in order to breach you again. So when an attacker breaches a database that has passwords that are salted, then they have to effectively recrack all the hashes all over again in order to get the plain text, which again just adds a little bit of additional protection. Because if you do say my secret password, once again as a plain text password, but then a different service adds a salt2, for example, and then that goes maybe to an e-commerce website, you'll see that the hash digest there is now completely different. So if they store those two different blocks within the database, then if some attacker is able to breach both of these two services, for example, they don't necessarily know that one hash is the same as the plain text of one hash is the same as the plain text of the another hash on another system there. So like I said, hashes are, hash digests here are irreversible. You cannot just take it and then say magically, let's turn that back into the plain text password there. There is no dehashing like we necessarily have with decryption. And that's a very common misconception there. Hashes are just completely irreversible. There's mathematically not a way to go back in that direction. So how do we do this? Well, we will need to crack it, and that's what we're going to talk about at the end. But first, in order to crack passwords, password hashes, we need to also understand the different kinds of hash digests that exist out there, because you need to be able to first identify the hash and then select the right algorithm to use in your password cracking operation. So let's talk about the taxonomy of these hash digests. So with the password hashes there, they're also almost always represented using hexadecimal for us as humans to see it. When you get that stored into the database, it effectively just gets stored as raw data. However, when it is presented as hexadecimal to us, that's a really easy way for us to actually be able to determine what is the particular hash digest algorithm that was used. So in this case, 4 bits of data is represented by 1 hexadecimal character. So what that means is that for every 2 hexadecimal character, that's 8 bits of data, which is 1 byte of data. So the major algorithms out there, MD5, which is the one that I've been showing you all, has a 128-bit digest. So that effectively equates to a 32-character hexadecimal output. So every single one of the hash digests that we've been seeing, they have been 32 characters in length, or approximately, or 16 bits to be exact. SHA-1 has a 160-bit digest, so you take 160 bits and then divide that by 4, as each character of hexadecimal is representing 4 bits of data. So that's how you get out 40 characters of hexadecimal. So on, SHA-256 is 256 bits, that's 64 characters in hexadecimal. SHA-384, same thing there, and then SHA-512, so on and so forth. So this is how you can start to identify which kind of hashing algorithm was actually used. So from earlier, if we had this particular block of data that was 32 characters in hexadecimal representation, which means that this is actually representing a 128-bit digest. And 128 bits digest is our friend MD5 right there. So that's how you take something that you don't necessarily know what kind of hash this is. You just simply map it to how many characters is it, that's how many bits it's representing. And then the most common type of hash is MD5 for this type of output. So now we go on to how do we crack passwords? That's the part that we've all been waiting for, right? So with passwords, there's a couple different ways that you can approach this. So with password attacks, the 2 main ones that are in use is either a brute force attack, which is literally making completely random guesses until the password validates. So that is a valid way of approaching it. It does take a lot of compute power in order to do this because you're making literally random guesses. And if there's any mathematicians in the room or statisticians, that domain becomes very, very large very, very quickly as you go through the possible permutations of potential passwords. Now, what is more commonly used is actually a dictionary attack. So you're making effectively informed guesses rather than making completely random guesses by using, for example, dictionary words or some known features, for example, pet names or birthdays, etc. Those are things that you would use in order to perform a more targeted attack against a particular individual if you want to get their password plain text. So the tool that we generally use for cracking passwords is a tool called Hashcat. So the Hashcat software is something that is pre-installed on Kali Linux. So if you have Kali Linux available, you already have Hashcat. If not, you can download it from hashcat.net, for example. I would highly recommend just using it within Kali instead of downloading it onto your actual host machine, just to have some level of isolation there with these kinds of tooling. Because a lot of times, if you're not used to these tools, you can inadvertently mess up your host system sometimes, and that's just a bad time for everybody involved. So let's take a look at the hash that we have from earlier, the 34cc, so on and so forth hash digest, right? So in that particular case, what Hashcat does is it literally goes through a word list that you supply to it, and it will go through and check one by one, does this hash match? So it'll go through password 1, hash it. What is it? Does that compare and match? Password 2, hash it. Does that compare and match? Password 3, hash it. Password 4, hash it, so on and so forth. So for every single one of these, Hashcat will just basically do an output comparison there. And you'll find that the very last one there is the one that matches. So Hashcat will be able to tell, okay, password 4 is the plain text that hashes into this particular hash digest, for example, and all the rest of them are definitely incorrect. And that is literally just under the hood. That is literally just what Hashcat is doing. It does also some additional optimizations. It can leverage things like GPUs, for example, in order to do this faster. GPUs are significantly better at doing hashing functions just due to the way that they're designed. CPUs are a lot more general purpose, whereas GPUs are specifically dealing with vectors and matrix algorithms and things like that. So hashing algorithms in general do a lot of matrix operations. So at the end of the day, it actually ends up being faster on a GPU, which is why you hear people say they need like an NVIDIA or an AMD card to do password cracking, for example. That's generally not necessarily required for, I would say, more casual password cracking. But if you're doing this on a more professional level, then you might require some GPU assistance there. So let's talk about go through a demo here on how to actually use Hashcat in order to crack some of these passwords. So within Kali, there's actually a word list that is readily available that we can use. So if you aren't sourcing your original word list about somebody, you can use a pre-generated word list that's included within Kali. So within Kali, there's a directory called in /user/share/wordlist. If you change into that particular directory, there is a file in there called rockyou.txt.gz. What you'll want to do is to decompress that particular file using gunzip, which will then, like the name there suggests, unzip the compressed word list file. Once the compressed word list file has been unzipped, if you want to see what's inside, you can run like head-m5 and on rockyou.txt, and then that will show you the 5 most commonly used passwords from RockYou. So you'll see a lot of these like very basic passwords, 1, 2, 3, 5, the password for literal password, or a password like I love you, which was actually very surprising when I first found it. I'm like, why would somebody put that as the password? Very strange. So what is this rockyou.txt here? Some of you might actually be familiar with it, maybe you're not. So RockYou was a social media add-on company that was very, very popular with MySpace users. And the very key word there was. They're now no longer in business. That is because there was a massive SQL injection vulnerability that effectively allowed attackers to gain access to their entire database. And then attackers also found that all of the users' passwords were stored in plain text, all of it. So at the time, this was back in 2009, it was reported that about 32 million user accounts on RockYou were stolen from this particular breach. And all of the users had their plain text passwords out there. So as a result from that particular breach, it was one of the largest breaches ever that contained plain text passwords. RockYou's leaked passwords are now used as a de facto word list for password cracking. And that's why you see it getting bundled within Kali on the word list directory. It is also sorted in the order of most commonly used to the least commonly used, because Hashcat and other password cracking tools out there will go through it from top to bottom effectively. So having it sorted by most popularly used, you'll probably get to the passwords a little bit faster versus having it in just completely random order. So let's now talk about preparing the hashes. So once we have the word list prepared, we're going to now prepare the hashes for cracking. So we can change back to our home directory. And then now what we want to do is to start inputting some of these hashes into a file. You can use a text editor like Vim, or if you're interested in like something like Sublime, whatever you're into, or as simple as literally running echo and then doing an output redirection into a file. So you can do echo, the hash there, and then output redirect that into hashes.txt. If you have more hashes that you want to crack altogether, for example, you can do more hashes into there. The hashes just literally need to be separated by a new line every single time, and the output redirection there, along with echo, will append that new line into it. So this will then put in a second hash into the file. So now if you cat out the file, you'll see that cat hashes.txt. It has two different hashes in there. And that's literally all you need to do to prepare the hashes. From there, now you have your word list and you have your hash prepared. It is literally now time to run Hashcat. So the Hashcat command looks a little bit like this. Hashcat along with a set of options, and we're going to talk about what each one of these options here mean. So the very first one right there, -m0, specifies the mode of hashes that Hashcat should be trying to crack. -m0 there means MD5 hashes. All the numbers for different modes are available within Hashcat documentation, so you don't have to guess these things. You just need to refer to documentation. Once you're familiar enough with Hashcat, you'll just start remembering off the top of your head, -m0, that's MD5. If it's an MD5 hash, I'll specify that. The next one right there is -A0. -A specifies the attack mode. The attack mode, like I said from earlier, there's like literally random guesses, and there's also dictionary attacks. Dictionary attacks are mode 0. Again, once you get familiar with this, you'll remember that off the top of your head. If not, documentation is always available. The next option there is -O, which is the output. This is where you're telling Hashcat to store the plain text password output. So tell it literally something like output.txt is probably fine. You want to name it something else, by all means, go for it. After you specify those options, it's time to specify the hash digest file. So we had hashes.txt, which is where we prepared all of our hashes. And then the last part there is to specify the dictionary word list. So in this case, we had extracted out the rockyou word list right there. And then we had done that within the /user/share/word list directory. So we'll need to make sure that we are specifying our full file path towards there. Otherwise, Hashcat will not be able to find that file because we are currently situated within the home directory right here. So these are files that we want to be put into the home directory. And this is the file that we already have in the home directory here. So once you have that command teed up right there, you can then just go ahead and run it. There is one thing that I would like to point out. Hashcat, if you're running inside a VM, in which case that is the thing that I generally recommend, you may and you probably 100% will encounter an error message that is very similar to the following. That will tell you that this is not a native Intel OpenCL runtime. You can use --force to override. Now, Hashcat wants to be able to leverage hardware optimizations wherever it can. So it's looking for the Intel OpenCL runtime. But since you're inside a VM, you don't really have some of those hardware acceleration available to you. So Hashcat generally complains about that. But like it says, you can use -- force to override. So the general recommendation here is to simply adopt the suggestion from that particular tool and then append -- force as an option at the end of your command there, and then you can just proceed forward. So just keep that in mind if you're using this within a VM. I have students that come to me all the time and say, hey, this is not working. And I always tell them, read the tool output. It's telling you exactly what you got to do there. So sometimes paying attention to that is very, very useful. So let's look at the output here from Hashcat. So once you execute that command, Hashcat will output a bunch of just these hypertexts, but it basically just gives you some status outputs on how long it's taking, things like that. So it'll say started at some point in time. It may take a little bit of time to run, especially on that very first run ever, because it has to basically start up all the first run type of things. You ever started up a program for the very first time ever, just need to do some initialization. But after it does that first time initialization, it goes a lot faster in the future. So once it's initialized and everything, you'll see that Hashcat will tell you it has stopped, and then you can cat out the file that we had there, output.txt, which is where we told them to save the outputs of the plain text password, and that is where you will see that the plain text cracked password is shown right there. So that very first hash that we have put in, password 4, was cracked, and then that second hash was something different, was New York City as the password there. So you'll see that this actually took not a whole lot of time. This took literally 3 seconds to run through. And this is just on my desktop machine at home, nothing fancy, running inside a VM as well, actually. So cracking passwords is very, very quick if you don't have some strong passwords available to you. So at this particular point, you're thinking, okay, 3 seconds, yeah, that's pretty fast, like pretty scary that somebody can just like crack a password hash like that, right? But you're probably thinking, oh, I add numbers and I add special characters to my password. That's way more secure, right? Well, let's show that. If you know that somebody is going to be adding numbers and special characters to their password, and a lot of people do add them in a very particular manner, you can actually take advantage of a really cool Hashcat feature to crack those kinds of passwords. So let's say we have 2 new hashes available. We don't know what they are yet at this point. We'll put them into a file, password hash1, password hash2. Now this time, we'll use pretty much the same Hashcat set of options available. Same thing, MD5 hashes. We'll tell it that the output file should be out_sp, and then our hash is h_sp.txt, and then we'll use the same dictionary there from rockyou, because we're assuming that people are still using pretty simple passwords there. But this time around, we're going to use a different attack mode. Attack mode number 6 is what's called combination attack. It is a combination of both a word list and a pattern. So in this particular case, we actually have a pattern that's specified at the very end right there, which is $D and $S, which stands for special characters and also number characters backwards, respectively. So in this particular case, what Hashcat will do is take each one of those rockyou word list entries and then append a numeric character and append another special character, meaning like your dollar signs, your @ symbols, your exclamation marks. Because a lot of the times when password requirements tell you, hey, you need an uppercase, lowercase, number, special character, and don't lie, some of you all here probably do this, is that you append some numbers and some special characters at the end of your passwords. And so this actually makes it really easy to then go and crack those passwords as well, because if you know those things, that's what people do, you can tell Hashcat to account for that as well. So in this case, if you try to run this, Hashcat will start again, initializing runtime, blah, 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 doing that. And then once it's done, you can do the exact same thing. cat out underscore sp, which is where we told them to save the file, and then that will show the cracked plain text password. This only took 17 seconds on a consumer grade desktop computer. Again, this is literally my desktop computer running inside of VM, nothing special about it. But in this case, somebody had tried to do New York City, $1 exclamation mark, New York City, $3 thinking that that is a little bit more secure. It is really not that much more secure if you're doing a lot of these predictable things at the end of your passwords. So this is still a highly, highly crackable set of passwords, even if you go in and start including numbers and special characters. So now we have talked about how to use something like rockyou, for example, to do this. And you can see that this is done pretty simply. If you want to get even more targeted at somebody, you can do what I call artisanal password cracking. So artisanal password cracking is just another way to say that you need to source your information about your target. So if you have a particular individual that you're looking to target, you'll generally want to collect some information about them through their social media, through their public records, for example, effectively doing open source intelligence or OSINT to understand a little bit more about this person's background there. And then from that, you'll use your targeted information that you've gathered to effectively then now build a word list. You can do standalone words, you can do a combination of words. You can also do the sort of combination attack with Hashcat from earlier. And then that's where you can configure those rules. You think they might be adding special characters or numbers. However, you're just based on your intuition and based on the OSINT material that you've gathered, that can help you inform some of the rules that you want to apply. Now, how do you actually go about doing some of these artisanal password cracking? Now, I'm not suggesting that anybody goes out there and tries to steal your friend's information, but this is something to generally look out for, right? A lot of the times on Facebook or on Twitter or whatever, somebody will be like, hey, you know, we're getting to know you better. Want to play this cool game? Tell us, where were you born? What year were you born? What street address were you born on? What's your first pet's name? What's your favorite color? What's your favorite band? What was the first car that you drove? Asking a lot of these questions, like outside of the context of security, might seem kind of benign, just like, oh yeah, somebody getting to know the you that they never knew, like, you know, from your past. But these are also the types of things that somebody would use as their password. They might use the year that they were born as part of their password. They might use their first pet's name, children's names. Those are very commonly used passwords. And a lot of people will use maybe their favorite bands, or maybe if they're a car enthusiast, they might use the very first car that they ever drove as part of their password. And because a lot of people build their passwords at a fairly young age, and you know, younger and younger these days, as more people get onto the internet younger, they're using a lot of these like sentimental things from earlier in their lifetime to inform their password choices. So when people are asking these like, you know, questions about your early lifetime attributes, it could be that they just kind of want to know you, or they're totally not a hacker and they're totally not building a war list against you. So these things are things to pay attention to. If you see folks on you know, Facebook and whatnot, I might want to give them a casual DM on the side to let them know, hey, might not be a super great idea, because this is just telling people your personal information at the end of the day, and that can really help somebody inform the word list that they built in order to try to like crack a password against you in particular. So all of this sounds, you know, kind of scary. So how do you actually protect yourself from password hash cracking? So there's a lot of ways that you can do very concretely to defend yourself from password hash cracking. One of the very first things that you want to do is do not reuse your credentials. Please, 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 please do not go onto youtube.com, have, you know, password1 as your password, and then also have facebook.com password1 as your password there. That's a really, really easy way for an attacker to breach one service and then just start reusing the password that they obtain from one service on another one. And then the second part here is to use a password manager. Password managers generate these super long, super random passwords with special characters mixed in random order there as well. And you'll generate one for each and every single unique service. That means that you won't end up in this situation where you have one service getting breached and then other services getting breached subsequently. If you imagine, for example, if Capital One gets breached, somebody's going to take your Capital One password and then just start trying it on Wells Fargo, Bank of America, Citi, JP Morgan Chase, etc. They're just going to try those things because they think, oh yeah, you're probably going to reuse the same password, right? But let's say if Capital One gets breached, but you used a random password for Capital One, and then an attacker tries to use that same password on, say, Bank of America, you're not going to get breached as a result because your Bank of America account has a completely different randomly generated password. And that's why I recommend everybody use password managers there. Password managers aren't difficult to use. They are, in fact, built into a lot of workflows, Google Chrome, Edge, and also Mozilla Firefox. All of them have a built-in password manager that you can use and that they're fairly secure to use. You don't necessarily have to use a paid service. You can use a paid service if you would like. There's some pros and cons there. The risk analysis is up to you to decide, how you want to mitigate your risk there. But one of the other key things I highly, highly recommend people doing is enabling multi-factor authentication across the board on anything that you deem sensitive. If you have like some random video game account that you don't care about, it's completely free, you have nothing to lose, maybe you have nothing to lose, right? But if your bank accounts, your things to access, like say government resources, for example, you might want some of those things to have multi-factor authentication on them in order to add an additional level of protection. So multi-factor authentication are those like security keys that you might see out there, or those security codes that your phone has. So one of those security keys might look like one of these, for example. These are YubiKeys, very popular amongst InfoSec professionals. So with multi-factor authentication, there's a few different attributes there. Multi-factor authentication is something that you have that's a physical object in your possession, right? So a USB key is something that you physically have access to. Unless somebody breaks into your house and steals it, which might be a threat that you face, but it's something that you keep in your possession that an attacker cannot obtain otherwise. Another factor in authentication is something that you know. So these are passwords. So passwords is already one single factor, hence something like a USB key here generates another factor, hence the multi-factor authentication portion. Other factors can also include something that you are, which is your fingerprint, your iris, your facial scan, your voice, etc. So you see things like Touch ID, Face ID, etc. Those things being used as a way to also authenticate individuals as well. There's also the option for somewhere that you are. It could be a physical location. For example, some kind of authentication may require that you must be in a physical location, for example, in a SCIF, in order to access something. So that's another level of authentication that may be required. One of the things here that I will say is that you should almost always avoid SMS or text-based multi-factor authentication, because hackers have been able to demonstrate that they can take over those cell phone numbers by socially engineering cell carriers. T-Mobile most notoriously, I don't know, like 4 or 5 years ago, got a bunch of numbers that got socially engineered from them. So attackers actually ended up transferring those phone numbers out of T-Mobile into another account that they control. And then so they just started receiving those multi-factor authentication codes on behalf of the victim. Now, T-Mobile has since done a lot to prevent that from happening, but all it takes is one customer service rep to mess something up and then get socially engineered, and then now your phone number is transferred out. So using one of those Google Authenticator app or Authy or Microsoft Authenticator, whatever one you're into, Duo also has an authentication option in there. Using an app like those is significantly better than using a text-based authentication code. Now, if you have no other option, like the service provider only offers text-based, do it. It's better than having none at all, right? So, but just keep the understanding that there is a risk involved with using those kinds of text-based authentication mechanisms. There is also another form that you can use to protect yourself, which is something that's called FIDO PassKeys. Now, with the latest versions of iOS and Android, these are widely available on both platforms. Windows is supporting it either now or soon. Mac OS also currently supports it as well. I'm sure if somebody's using like Chromebooks, they'll be supporting very soon as well. Most of the modern browsers are supporting this even within Linux as well. So there's just a lot of widely available support now. This is effectively turning your phone into effectively a YubiKey, because not everybody will have access to a YubiKey. Maybe somebody doesn't want to pay $50 for the YubiKey, and then people can simply use their phones instead. And so the phones effectively act in replacement of the YubiKeys, and then we'll do these kinds of public key-based authentication against a particular service, for example. So instead of plugging in a USB device, what you're doing is you're authenticating yourself using your fingerprint or your Face ID to your phone, and your phone is then sending a cryptographic signature back out to the service in order to authenticate that you are indeed the person. So these are just about as secure as a physical key, assuming that nobody steals your phone. If somebody steals your key, you have the same problem there, right? Nobody steals your phone, nobody knows the password to get into your phone, then that is a very, very safe and secure way to implement multi-factor authentication using FIDO PassKeys. And this is like existing technology, because these USB security keys have been using something that's called the WebAuth API, and those APIs are existing. Browsers, like I said, are supporting the phone-based version these days as well. And all you need to do is just point your phone onto like a QR code on the screen, scan it, and then it'll do the exact same thing. It'll just run it over Bluetooth instead of over USB there. And all of that is encrypted from end to end there as well. So it's a very secure way to do that. So again, if you don't want to pay $50 for like a little USB security key, you can use your phone. And in fact, I've started transitioning some of my stuff onto my phone just because I don't carry my security key with me to everywhere. And that's a much more convenient way of using multi-factor authentication there as well. So with that being said, congrats. You all have learned how to crack password hashes and also learn how to potentially secure yourself from these things as well. So if you have questions, feel free to get in touch with us. contact@Skyline.com is the best email. I'll hit our entire team actually. So if y'all got questions or anything, feel free to get in touch with us. Tomorrow's CTF is hosted on Cyber Skyline, and password cracking will be a very useful skill to have in tomorrow's CTF. So with that being said, happy to take any questions here. If anybody's got any questions, I have not been paying attention to the chat, so I apologize. Thoughts on the XKCD comic there? Yeah, the correct horse battery stateful. So it depends. It's again one of those things where if people know that's the pattern that you're using, they'll just generate a English language dictionary. They'll pick 4 words or 5 words at random, and then start brute forcing using a dictionary on that, right? So it depends, because that one assumes that somebody is guessing at random only. So they're purely doing brute force only. Generally, I would recommend using a completely randomly generated super long password, because it's way harder to break that. Because again, the domain for the possibilities is just way larger versus standard English language words there. So that is, that is going to be what I would generally recommend. I think all my passwords are like some more than like 20 characters, and then they're also generated at random. So it's like varying between like 20 characters and 40 characters at random, so that they're not all the same character length either. Just so that you can have some variations in there. So if somebody knows that I use a password manager, they can just say, oh, I know that they always have a 20-character password, and I'm always going to try to generate a list of 20-character random passwords, for example. So a lot of those things, a lot of those things can be useful. There was a question about how can we find out what kind of MFA a company uses before signing up. It's pretty much not really a good way to do that. you kind of have to sign up, go in, and just see what's in there. I don't think any company out there really advertises what kind of MFA they offer, unless it's like a very security-oriented company. But yeah, even things like security cameras or like Amazon and whatnot, you really only find out after you sign in. Maybe there's like help documentation, but it's just going to be easier for you to sign up for an account, go in, and then figure it out. Norton Password Manager, I've personally never used it, so can't recommend nor recommend against. So something for you to maybe, potentially just investigate if it works for you or not. Dashlane, I know, has a lot of sponsorships on YouTube and whatnot. I'm not a personal user of it. Haven't really seen anything negative or positive about it other than just the YouTube sponsorships. I know a lot of InfoSec professionals really like a particular one called Bitwarden, which offers both a hosted version and also an open source version as well. The code for Bitwarden is entirely open source out there, so you're welcome to host like a personal version. I would generally, if you're not familiar with like hosting stuff on your own, generally recommend against it, because if you lose that particular server, you all of a sudden lose all of your passwords, which would just be not a great time for anybody involved. So that's the only recommendation that I would have in terms of password managers. Personally, I use a Chrome extension, but all my passwords eventually get saved into Google. And then all of it gets there's a security key authentication on it. I feel like I shouldn't be telling you all this because I'm literally telling you how to attack my password manager. So, but yeah, that's one way to go about it as well. But any password manager that you use, make sure that the password manager itself, what they call the master password, that is something that you know, and that is something that is super, super secure. And also you may want to enable multi-factor authentication in order to access that account as well. Because if you use the password manager, but the password to your password manager is really bad, all that somebody needs to do is crack your password manager, and then boom, they have all of your other passwords as well. So that is kind of a single point of failure, which is why having multi-factor authentication is really good, to make sure that you do have a security key, for example, or at minimum use like the phone PassKeys there in order to protect yourself from that kinds of attack against your password manager. But yeah, for me at least, like trusting whatever brands you may trust at the end of the day. I know lots of friends on the Google security team, so inherently I'm a little bit biased and sort of trust Google's overall security. Other people may vehemently disagree with me, and that's completely fine. At the end of the day, it's your whatever risk posture that you want to take yourself. So.
Okay, well, Toby, thank you so much. This was a great presentation.
Of course. Any other questions I can help answer? If not, I'll be around both days here as well. Feel free to hit me up on Slack or whatever. But tomorrow CTF is the folks at Personal Engineering have created a really, really fun CTF. So, and I know password cracking is going to be a part of it. So it'll be a very fun time for everybody.